Hello guys, so today we'll continue reviewing for exam 2. Question number 22. This question is from chapter 3. It's about the straight lines. Let's see what's going on in this question. Write an equation of the line in the figure below. So the graph of the line is given. We are looking for the corresponding equation. Let's read the information in the parentheses. It says simplify your answer. Type your answer in slope-intercept form. Use integers or fractions for any numbers in the equation. That means we do not use decimals. And also we need to write the equation in the slope-intercept form. The formula for the slope-intercept form is y equals mx plus b. So,
Hey, Professor.
yes.
I was just letting you know that Wyatt's here. I was just a little bit late.
Oh, okay. So give me 1 second. Let me do it now, because otherwise I might forget later. Today. Edit. All right, it's fixed.
All right, thank you.
No problem. The graph is given, right? Slope-intercept formula y equals mx plus b. To answer the question, we need to find the slope and y-intercept. Let's see. Can we find a y-intercept first? Look at the graph. The red dot here is the intersection of the straight line and the y-axis. Could you identify the coordinates of the intersection? I can make it bigger. Make it bigger. So do you see the y-intercept? Anybody can help me to identify the value for b? It's a negative, right? Because it's below the origin. I think it is -1. Awesome, very good. It's a -1, right? Yeah, perfect. So b equals a -1. This is the origin, and the red point is below, 1 unit below the origin. So value of b is a -1. And what about the slope? Slope equals rise over run. I would consider, one way to consider is to use the two given points, the two given red points, and I'm going to make a right angle triangle like that. And the length of the vertical leg would be the rise. The length of the horizontal leg would be the run. So from A to B, let's say this is A, this is B. If we go from A to B, the rise is a positive, right? Let's see how many units from A to B vertically. So we have 1, 2, 3, 4, 5. Rise is a positive 5. That's what I see. And then run from A to B is also positive because from left to the right. So 1, 2. So the slope I found is 5 or 2. Let's see if you have the same thing. Exactly. Very good. 5 or 2. Rise over run is the slope. Slope is 5 over 2. So once we have the values for the slope and the y-intercept, we are able to find the equation for the straight line. Is y equals 5 over 2x minus 1. Do not use a decimal again. Read the instructions. I know 5 over 2 is 2.5. but we do not use 2.5. Keep it as a simplified fraction. Let me type the answer here. Y equals 5/2 x minus 1. All right, I think this is pretty clear, right? Y-intercept is the intersection of the straight line and the y-axis. B in the formula is the y value of the y-intercept. And slope, how do we find the slope from the graph? We have the two red points given, so we can create a right angle triangle and find the rise and run. And we find the slope is 5/2. Very good. Next question is to multiply two binomials. I think multiplying binomials in the class I introduced like 5 methods, right? But I hope you settle with the box method, not just for multiplying two binomials, for any multiplication of polynomial problems. When we multiply two polynomials, we use the box method, can find the product very quickly. In this case, we have a binomial times a binomial. So we are going to create a 2x2 box, 2x2 box. And I'm going to place one binomial to the side of the box. 3x minus 4, the first term is 3x, the second term is -4. Be careful with the sign. -4, the negative sign is a part of the term. And the second binomial, x plus 5y, we are going to place that on top of the box, x plus 5y. And now let's multiply the corresponding terms to fill in the 4 blanks in the box. Row 1, column 1, 3x times x, 3x times x. You really don't have to do that in your head. Like what I wrote here, you write down on your scratch paper, then you can see it better. And the result is not 4x, by the way. The result is 3x squared. Be mindful, you are multiplying, you are not adding. 3x times x is 3x squared. Now we have row 1, column 2. Row 1, column 2 is 3x times 5y. 3 times 5 is 15. X times y, keep as x times y. Row 2, column 1, we have 94 times x. It's simply just 94x. The last cell, row 2, column 2, 94 times 5y. 94 times 5, -20. Keep the variable y. So those are the 4 terms in the box. And we are going to add them up to give us the result, the product of the multiplication of the two polynomials. So we have, in this case, let me double check, 3x minus 4, 3x squared, 15xy, -4x, minus 20y. In this case, none of the 4 terms are like terms, right? So the diagonal pattern doesn't hold. And the reason because we have a second variable in the second polynomial. So be careful when we are not be able to combine them because they are not like terms, we have to keep them wherever they are. So the result is going to be 3x squared plus 15xy minus 4x minus 20y. It's going to be a polynomial, multivariate polynomial. In this case, the polynomial has 4 terms. Let me know, do you have any questions? And this is already simplified. The 4 terms, none of them are like terms. We have nothing to combine. Oops. Okay, so I can quickly type the answer in here. So we have 3x squared be very careful, 3x squared plus 15xy minus 4x minus 20y. 3x squared plus 15y minus 4x minus 20y. Let's see any questions? I used the repeated distribution for this one. Yeah, that's the method I use actually. Just now when I entering the answer, I wasn't copying what we had earlier here. I actually using the repeated distribution method in my head. Thank you, Amanda. It's the same answer, right? With yours. All right, so let's continue. Next question. This is about chapter 3. For the equation 8y equals 2 plus x, answer part A through part B, only two parts. Part A, state the x and y intercepts. Part B, use the intercept method to graph. Okay. Firstly, let's recall the definition for x-intercept and y-intercept. X-intercept is the intersection of the given straight line and the x-axis. It is a point with two coordinates. Y-intercept is a point corresponding an ordered pair as well. And that point is where the straight line cut the y-axis. So that's the definition for x-intercept and y-intercept. So let's see, how do we find x-intercept and y-intercept? This is the equation. To find the x-intercept, x-intercept, make y be 0. So in the equation is 8y equals 2 plus x. We make y be 0, so the left side, 8 times 0 equals 0. So we have a 0 on the left side, and then we have 2 plus x on the right side. Which number plus 2 gives us 0? -2. So x has to be -2. You can get x equals -2 by moving the 2 over to the left side. So x equals -2. So the x-intercept is -2, 0. X-intercept is -2, 0. We find the value of x by making y be 0. And this pair is the x-intercept. And to find the y-intercept, we make x be 0 in the equation. The equation is 8y equals 2 plus x. We make x be 0, so the right-hand side only has a 2. 2 plus 0 is just a 2, right? So we don't have to write a plus 0 here. And on the left side, we have 8y. Solve the equation for y. Divide each side by 8. And we have a y equals 2 over 8. That is 1 over 4. So the y-intercept is 0, 1 over 4. All right, so those are the intercepts. X-intercept, -2, 0. Y-intercept, 0, -4. Very important thing is x-intercept must have the second coordinate as 0. Any x-intercept, by the way. The x-intercept you found has to have the y value 0. And the y-intercept must have x value equals 0. So that's something we have to memorize and understand. It's because x-intercept is on the x-axis, so the y value is 0. Similarly, y-intercept is a point on the y-axis, That's the reason the x value has to be 0. Let's enter the values in the question. I have -2, 0, type and order the pair. So we have here the option to choose, and -2, 0, and y-intercept, this one, 0, 1/4, right? Let me see, 1/4. I use this, oops, so be very careful. Double check your entry before you submit. It's 1/4, and that's the part A. And we are going to plot the 2 points and graph the straight line. Click and choose this. This is very tiny for me to see. You probably have the same problem because when you go to testing center, you need to use the lockdown browser and you will not be able to zoom in, make it bigger. You would have to be very, very careful and look very close to the screen. What is the, so 92, 0. This is very difficult to, 92, 0. I think it's here. And 0, 1/4, right? So if this is 1, 2, 3, 4, so that is like that. Let me give it a try and let me look closer. This is closer. This is clearer. So this is the orange, I believe. And x-intercept -2, 0. That's correct. 1, 2, 3, 4. 1, 2, 3. This is 91. 1, 2, 3, 4, 92. Okay, so this is the orange. Go up 1, 2, 3, 4. So make 1. So that is a quarter. Okay, that's correct. So be very, very careful. Any question about this problem? This is a good question. It tests the definitions of x-intercept and y-intercept. And there are 2 points on the straight line. So if we plot the 2 points and then connect the 2 points, we will have the graph of the line. Finding x-intercept and y-intercept is one way to graph a straight line. Any question? I'll count to 5 and then I'll continue. See. Okay, thank you, Jill. Next. Okay, thank you, Keelan. Next, number question 25. We are multiplying. We are multiplying a monomial by a trinomial. Monomial times a trinomial. The method we use is the distributive property, right? If you want, you can still use the box method, by the way, if that helps you. Since monomial has 1 term, trinomial has 3 terms, we are going to make a 3x1 box or 1x3 box. I'm going to make a 1x3 box. This way, the box is more stable on the ground. So I'm going to put a monomial on the side of the box is 6xy cubed, and then the trinomial on top of the box, 2x cubed y cubed, that's the first term, then 4xy, that's the second term, which is a negative, and 5. Okay, so let's multiply. Row 1, column 1, we have 6xy cubed times 2x cubed y cubed. And let's see, how do we multiply the 2 monomials together? A lot of variables, right? So don't rush. We take time to look at the parts. Firstly, multiply their numerical parts. 6 times 2 is 12. And then we look at the parts with x. We have 1x here. We have 3 x's multiplied together here. So x times x cubed gives us x to the power 4. And we have a y cube here and another y cube here. Y cube contribute 3 y's multiplied together. And we have another y cube, so we have 6 y's. That gives us y to the power 6. So the first cell, we have 12x fourths y6. And the second cell, we have 6xy cubed times -4xy. Very important. This is not 6xy cubed minus 4xy, okay? It's not. It is 6xy cubed times -4xy. We are multiplying. Positive times negative gives us negative. 6 times 4, 24. X times x, x squared. Y cubed times y, y fourth. So we place that term in the second cell. -24 x squared y to the power 4th. Let me erase those. And then we have one cell to fill in. Row 1, column 3 in the box. So we have 6xy cubed multiplied by 5. Oh, that one is simple. Multiply the numerical parts. 6 times 5 is 30. And then keep whatever the variable parts in 6xy cubed. Because the 5, this term doesn't contribute any variable. So keep the x, keep the y cubed. And the result would be the addition of the 3 terms in the box. And if you look at the 3 terms in the box, none of them are like terms, so we have nothing to combine. All right, let me enter the answer. When I enter the answer, I'm actually using the distributive property. 6 times 2 is 12, x to the power 4th. Y to the power 6. Second term is a negative, so minus 24 minus 24 x squared and negative 24x squared y fourth, y to the power 4. You have about, oh, really? Oops. This is to the y to the power 4th. And the last term is plus 30 xy cube. Xy cube. All right, double check it before you submit. We are taking time, so we run out of time. 12, double check, 12x fourth, y 6 power minus 24x squared y to the power 4th plus 30x cubed. Okay, correct. Next, this is chapter 3. 6 points are plotted in the figure. Determine the ordered pairs that represent the points. So this is about the definition of rectangular coordinate system. In a rectangular coordinate system, points are defined as ordered number pairs, 2 components. Let's see, point A. Point A is this red one, type and ordered pair. So press this key. And point A is very testing my vision. I think it's a -8, -2, -4, -6, -8, -8 comma -2, -8 comma -2. And point B, where is B? Oh, this one. So 1, 2, 3, 4, 5. -5 comma -1. -5 Let me know if you have a different opinion. -5 over comma -1. That's B. C, or C is here, quadrant 3 as well. 1, 2, 3, -3 comma -3, -3 comma -3, -3 comma -3. Point D, D is also in quadrant 3, -2 comma -6, I would say. -2 comma -6. -2 comma, oops, you see, sometimes I type the -2 comma -6. 92 comma 96. Okay. Point E is on the y-axis. The orange color or yellow orange color is 0 comma -4. 0 comma -4. Point F. Finally, we got a point that's not in the quadrant 3. Point F in quadrant 4. So 4 units to the right, 7 units below. So 4 comma -7. 4 comma -7. Guys, let me know. Do you see the same? It's very small. I think you can amplify. That function should work even with the lockdown browser. Okay, thank you, Joe. Same with mine. So let's move to the next question. Question number 27. Subtract. Let's see, how do we subtract? We are using a binomial to subtract, to minus a trinomial. We use a horizontal method. I'm going to use a horizontal method. So horizontal method is to remove the parentheses. We have two parentheses. In order to remove the parentheses, we need to identify the coefficient. Then we can apply the distributive property to remove the two parentheses. The first parenthesis has coefficient 1, and we know 1 is the multiplicative identity. 1 times anything is just the thing. So the first parenthesis, we could really literally remove it and keep the two terms exactly the same way they are in the parentheses. In the second parenthesis, the coefficient is a -1. I hope you can see that. Is a -1. So when we remove the parentheses by using the coefficient, by distributing the coefficient -1, all the terms in the parentheses are going to become their opposite, because -1 times a quantity will give you the opposite of the quantity. So 2x4 is positive. After we remove the parentheses, it's going to become negative 2x4. Positive x cubed become negative x cubed. Negative 5x becomes positive 5x. Become their opposites. And now let's see, do we have anything to combine? We have this and that. We can combine those two, and we can combine those two. 5x fourth minus 2x fourth gives us 5 minus 2 is 3, 3x to the power fourth. 8x plus 5x, 13x. 3x fourth, 13x. And then we have one more term is minus x cubed. So 5. So we have 3. I can write them, switch the order. I write negative x cubed in front of 13x because that term has a higher exponent. All right, do you have the same thing? Do you have any question about how do we remove the two parentheses? And did I combine the like terms correctly? 13x. Okay, it's correct. All right, perfect. I need to remember the thing. 3x force. Well, we can't just skip it and just keep to go to the next question. This one is division. Okay. We went over long division on Monday, the beginning of Monday, right? When do we use long division? When we need to divide polynomials when the divisor is not a monomial. If the divisor is a monomial, we have a different method. When the divisor is not a monomial, like this case, the divisor is a binomial, 3x plus 6, then we use long division. The method we learned in this class is long division. Okay, to get ready for the long division, we need to firstly identify dividend and the divisor, because the two polynomial divisor play different roles. Remember, the polynomial in front of the division symbol, that's the dividend. The polynomial behind the division symbol, that's the divisor. Okay? And we need to make sure both dividend and the divisor are written in a standard form. How many to check? Look at the dividend. Degree is 3. And then we have a 3, 2, 1, 0. And divisor degree is 1. We have 1, a constant. How many to check? Are those two polynomials, the dividend and the divisor, already in a standard form? How many to check? Are they already in a standard form? Yes, they are. Sometimes they might not, then you have to modify, right? Like the example I gave you on Monday. So once they are in a standard form, we place the standard form of dividend under the roof, the division notation. 9x cubed plus 3x squared minus 36x minus 12. And then place divisor next to the symbol, 3x plus 6. And let's start the long division process. Remember the procedure is divide, multiply, subtract, compare, and bring down. We might need more than one round. Okay, I'm not going to go very detailed like last time. I'll go a little bit faster than last time. Okay, divide what? Divide the leading term in the dividend by the leading term in the divisor. Quotient rule, 9 over 3 is 3, x cubed over x squared. And I place the quotient right here on top of the roof. And then multiply the quotient we just got by the divisor. Divisor is 3x plus 6 right here. Distribute, 3 times 3 is 9, x squared times x cubed. 3x squared times 6, 18x squared. And I'm going to place this multiplication, the product, right under the dividend. So 9x cubed plus 18x squared. And then we subtract. Instead of subtracting, we change the sign and then do the addition. 9x cubed, negative 9x cubed cancel each other. 3x squared, negative 18x squared gives us negative 15x squared. The remainder has degree 2, which is bigger than the degree of the divisor, which is 1. The divisor has degree 1. So we're going to continue by bringing down the next term in the dividend. So it's negative 36x. And now on the bottom, negative 15x squared minus 36x is the new dividend. So we are going to start the second round. Use the leading term in the new dividend divided by the leading term in the divisor. And we have 95x. And we put the 95x on top of the roof. align with negative 36x. And then we multiply the quotient we just got by the divisor, 3x plus 6, distribute negative 15x squared minus 30x. And we place that right under the dividend. And then we subtract. And instead of subtracting, we change the sign and we do the addition. Both of them are negative. I change them to positive. Negative 15x squared, positive 15x squared cancel each other. Negative 36x, positive 30x, we have negative 6x. Compare. This remainder has degree 1, which is not strictly less than the degree of the divisor, so we have to continue bring down the last term, negative 12. And then we start the third round. Divide the leading term in the new dividend, which is negative 6x, by the leading term in the divisor, 3x. Quotient is negative 2. Put the quotient right here. And then multiply the quotient by the divisor, 3x plus 6. And then the result is negative 6x minus 12. And then put it here, negative 6x minus 12. And then subtract. This subtract is very straightforward because they are the same thing, right? Negative 6x minus 12 minus itself, we have 0. Remainder is 0. It means in this case, the divisor, the binomial 3x plus 6, go into the dividend completely because the remainder is 0. It doesn't happen all the time, but in this case, it happens. So when the remainder is 0, we could just write the result as a quotient. This is the quotient. The result in this case is a polynomial. Okay, 3x squared minus 5x minus 2. Do we have any question about that? The result is 3x squared minus 5x minus 2. It's up. Okay, sorry. We were on question number 27. 3, oh, that one. Did I do it wrong? Oh, I did not enter that. 29. 3x squared minus 5x minus 2, same with our answer, right? And let me know, do you have any question about long division? I actually recommend you rewatch the part from Monday recording because it takes time. And let me show you long division, very organized. So as you can see, this column, cube, right? X cube. The yellow column are X cube. And this blue column, square, 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 right? And this green column, X, 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 right? And this, let me try purple column, -2, and the constant, 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 and constant. So long division, the alignment is very important. Column by column, vertically aligned terms are all like terms. It's pretty neat. This word, NEAT. All right. Any questions? You might have a question because the long division I know is challenging. But I will continue because we don't really have time to redo it. Multiply, use the special formula that applies. Okay. Let's do not look at the answer and we work on the problem on the note here. The intention of the question is to apply the formula. Let me write a formula for you. The formula is a plus b to the power of 2 equals a squared plus 2ab plus b squared. On the left side, we have a square of binomial sum. Turns out a square of binomial sum is a perfect square trinomial with the middle term positive. And the perfect square trinomial is very symmetric, very symmetric. This term is the square of the first base, the first item in the parentheses, first term. And this is the square of the second term. And in the middle, we have twice of the product of the two items. So in our problem, A is the 3x. This is our A. And this is our B. Okay? So when we use the formula, we're going to have a trinomial, perfect square trinomial, with the first term, square of 3x, last term, square of 4y. In the middle, we have twice of the multiplication of the two bases. You see that? See 3x as one whole thing. That's the first base, or the first item in the sum. And see 4y as the second item in the sum. And in the middle, we have twice of the multiplication of the two items. And then we simplify in the next step. 3x squared. 3x squared is 3x times 3x. So we're going to have 9x squared. In the middle, we have 2 times 3 times 4. That is 24xy. And the last term, 4 times 4, 16y squared. So that's the answer. If you really have trouble to apply the formula, which I believe some of you do have trouble to apply the formula, you can use the box method. Important thing is you get a score when you take the test, right? So let's use box method. Use box method, we are multiplying 3x plus 4y with itself. Binomial times binomial, we need a 2 by 2 box. 3x, 4y, 3x, 4y. Multiply. Row 1, column 1, 3 times 3, 9, x times x, x squared. Row 1, column 2, 3 times 4, 12, x, y. Row 2, column 1, 4 times 3, 12, x times y, or x, y times x the same, so x times y. Row 2, column 2, 4 times 4, 16, y times y, y squared. And in this case, the diagonal pattern display. The two terms in the diagonal, they are like terms, so we are able to combine them. Combine them as 24xy, right? So the result is going to be 9x squared plus 24xy plus 16y squared. Do you agree, guys? For the coming exam too, if you really have trouble to apply the formula, it is okay to use the formulas. That is one way to get around the formulas. Let me know your question. Okay, thank you, Jill, for your response. And the same answer with us, or ours, right? Next, simplify. Simplify, and I see a power of a product first. The base is a product. First factor is 2, second factor is x power -5. So I'm going to apply the power of a product equals the product of powers. Apply the x power -5 on shoulder of 2, and then apply the exponent -5 on the shoulder of x to the power -5, like that. Okay, apply the -5 exponent on each part in the multiplication, like that. And let's continue. 2 to the power -5. The negative sign in the exponent works as reciprocal. Okay, if we want to remove the negative sign, it's okay, get rid of it. And the left over is 2 to the power 5, but we need to put it in the denominator. Get rid of the negative sign, and we have a left over 2 to the power 5, but we need to take the reciprocal of that leftover. Multiply by x to the power -5 and then to the power -5. That is a congruous structure. That is a congruous structure, like layers. So we keep the base of the base, x, and then multiply the two exponents. -5 times -5, positive 25. And now we have 1 over 2 to the power 5 times x to the power 25 over 1. X to the power 25 actually is in the numerator. And then we multiply across. We have x to the power 25 on the top. We have 2 to the power 5 on the bottom. Do we need to write 2 to the power of 5 as a 32? Let's read the instruction here. Use the positive exponents only. Use integers or fractions for any numbers in the expression. Simplify your answer. That means we do have to write as 32. So that, as I see, you can see here is 32. Because 2 times 2 times 2 times 2 times 2 is 32. And that's the answer. Read the instruction before you submit that specific question. Any questions about this problem? Okay, so let's move to the next question. Without the graphing, determine whether the following pair of lines are parallel, perpendicular, or neither. Okay, let's do not look at the answer. Let's do that on my note. Parallel. The theorem says two straight lines are parallel. Let's say L1 and L2. If and only if they have the same slopes. For two straight lines to be parallel, they must have the same slopes. For two straight lines to be perpendicular, their slopes must be the opposite reciprocal of each other, or the slopes must multiply to -1. So that's the theorem we need to apply to answer this question. Anyway, we need to find out the slopes for both two straight lines. Let's look at the first straight line. Y equals 3 over 4x minus 1/2. This equation, the first straight line, the equation is in the slope-intercept form. So you can tell the slope m equals 3 over 4, right? So let me write it down. The first equation, the first straight line, has a slope of 3 over 4. Because the equation is in the slope-intercept form, we are able to identify it directly. And the second equation is in the standard form, 4x plus 3y equals -8. You can use my method if you still remember this method, or you can modify, rewrite the equation in the slope-intercept form. Either way, whichever way you feel more comfortable. If we rewrite the equation, we can move 4x over. We have -4x, -8 stay on the right side, and then divide everything by 3, by 3, by 3. 3 cancels 3, we have a y isolated. On the right side, we have -4 over 3x minus 8 over 3. So the slope of the second straight line is -4 over 3. negative 4 over 3. Sometimes I even use both methods just to make sure the answer is correct. Let me know if I went too fast here. What happened is the second equation is in the standard form. If you do not want to memorize one extra formula, you can rewrite the equation in the slope-intercept form. It's pretty convenient. We move 4x over, we negative 4x on the right side, and then divide everything by 3 to isolate the y on the left side. Then we have a y equals negative 4 over 3 times x minus a over 3. And that equation right now is in the slope-intercept form. Y equals mx plus b. So the slope is negative 4 over 3. And look at the two slopes. The first straight line, slope is 3 over 4. The second straight line, slope is negative 4 over 3. As you can see, they multiply to negative 1. The two slopes are opposite, reciprocal of each other. This is a positive, this is negative. On top of that, this is 3 over 4, and that is 4 over 3. So they are opposite, reciprocal of each other. If you multiply them together, you must have negative 1. So that's how we know the two straight lines are perpendicular. We should choose perpendicular, right? Perpendicular. Let me know, do you have any questions? How do we find the slopes for the two straight lines? Do you have any questions? Okay. All right, thank you. And next, multiply monomial by trinomial. Okay, so let's practice that here. We use distributive property. Or as I mentioned, we can use 1 by 3 box, right? Write a monomial on the side of the box. Write a trinomial on top of the box. 9x cubed, negative 5x squared, 6x. Now let's multiply. Row 1, column 1, negative 3x cubed times 9x cubed. Negative 3 times 9, negative 27. X cubed times x cubed, x to the power 6, x to the power 6. We have 3x here, 3x's here, so 6 of them. Next cell, we have negative 3x cubed multiplied by negative 5x squared. Negative times negative is positive. 3 times 5 is 15. X cubed times x squared, x fifth. Next cell, row 1, column 3, we have a negative 3x cubed times 6x. Negative times positive, negative 18. X cubed times x, x to the power 4th. So negative 18, x to the power 4th. And the result would be the addition of the three terms. We have negative 27, x to the power 6, plus 15, x to the power 5th, minus 18, x to the power 4th. Let me know if you have any questions. We've seen this question in the same set, right? Same with our answer. Okay, very good. Continue. Combine. So not combine, actually it's a subtraction. This is difference of two polynomials. This is about difference of two polynomials. I feel like we just had a similar problem, right? And horizontal method. The first polynomial, the first parenthesis, has coefficient 1. Second parenthesis has coefficient -1. Since the first parenthesis has coefficient 1, we are able to literally remove the first parenthesis. So all the three terms in the first parenthesis are going to remain the same. 3x squared minus 3x minus 9. Since the coefficient of the second parenthesis is -1, when we remove the parentheses, all the terms in the parentheses are going to become their opposite. So here, -5x squared will become positive 5x squared. Positive 5x is going to become -5x. 9 is going to become -9. And then let's see, can we combine like terms? So we have this one, like terms, and this is this, and this and that is like terms, and this one are like terms. 3x squared, 5x squared, add up to 8x squared. -3x minus 5x, -3, -5. You lose the game. The first game you lose $3, and then the second game you lose $5. So you -8, right? Lose $8. 8x, -8x. -9 minus 9, -18. That's the answer. Questions? Be very careful with the sign. When we're subtracting, whatever inside the second parenthesis, once we remove the parentheses, they are going to become their opposite. Okay, thank you. Next. Graph the following equation by plotting 3 points and connecting them. Use a table of values to organize the ordered pairs. So basically, we're graphing the line, right? We don't have to use the instruction, what the instruction says, 3 points. We can use whatever we feel comfortable, right? What I would do is firstly simplify the equation. The equation right now is not in any one of the 3 forms we have learned. We have learned the standard form, slope-intercept form, point-slope form, and this equation is not in any of the forms. But I can quickly or very conveniently rewrite the equation in the standard form, simply by moving 3 over to the right. 3 become -3 on the right. And I would have 2x plus 3y equals 9 minus 3, 6. I can very quickly rewrite the equation in the standard form. This is the standard form, by the way. ax plus by equals c is the standard form. I'm not sure if you remember, I mentioned this, and I recommend that you include that rule in your note. When the equation is in the standard form, using the x-intercept and the y-intercept to graph the line is very convenient. That's the rule. So let's see how or why is convenient when the equation is in the standard form. Okay, we are going to find the x-intercept and the y-intercept. Yeah, please look at what I'm going to do, okay? To find the x-intercept, we make a y be 0. Make a y be 0 means this term gonna disappear, right? Yeah, there was a 3y there because you make y be 0, that term disappear. And tell me what is x. If 2x is 6, x is gonna be 3, right? I believe most of you can get that done in your head. 2x equals 6, x equals 3. Yeah, let me do it again. there was a 3y here. When we are looking for x-intercept, we make y be 0. Make y be 0, you plug in here y equals 0, and this term becomes 0, right? This term is going to disappear. This term is going to disappear. I think the reason it really disappeared because when I do this, kind of like this AI, the AI think I'm going to erase that. So it really make it disappear. This is a new function I just discovered for the OneNote. So the x-intercept is 3, 0. And there was a 3y here, by the way. All right, very convenient. For finding the y-intercept, we make x be 0, right? We need to make x be 0. So in the equation, we make x be 0. So this term is going to disappear because 2 times x is going to be 0. You see that? And that term disappear. Now you only have 3y equals 6. If 3 times y equals 6, then y is going to be 2. I believe most of you can get that done in your head, right? 3y equals 6, then y equals 2. Y has to be 2 for 3 times 2 equals 6. That equation to be true. So the y-intercept is 0, 2. Right? And once you have those 2 points, you can graph the line by using the 2 points. 3, 0 is here. 0, 2 is here. And you connect them. And that's the straight line. And let me know if I'm clear. Again, when the equation of the line is in the standard form, using the x-intercept and the y-intercept to graph the line is pretty convenient. As I show you, it's very convenient to find the x-intercept and the y-intercept, right? Okay, thank you, Amanda. Then we can move to the next, the same with ours. 0, 3 is here, 0, 2 is here, a line here. Next, find an equation. Let me copy, paste. Find an equation of the line. Write the equation in the standard form. We must pay attention to the requirement. A lot of times, the question requires us to write in the slope-intercept form, right? But not always. We really have to pay attention and read the question. We need to find an equation passing through 3, 8 and parallel to 6x minus y equals 7. Okay, we had a similar problem in our class worksheet. But in the example we have in the class worksheet, we write the result in the slope-intercept form. We can do that and then rewrite the slope-intercept form to the standard form. So that's my plan. So firstly, I wanna, since we would let L be the line we are looking for. Since L is parallel to 6x minus y equals 7, the slope of L equals the slope of 6x minus y equals 7. Okay, I give you 1 minute. Can you help me to find the slope for 6x minus y equals 7? And share your answer in the chat. Since the line is parallel to the given straight line, 6x minus y equals 7, they have the same slopes. Please help me to find the slope for 6x minus y equals 7. Anybody want to share an answer? What's the slope of 6x minus y equals 7? One way you can get it done is to write the equation in the slope-intercept form. Be careful with the sign. So if we do this, I use my transposition of terms. I'm going to keep 6x on the left side, move the 7 over, move the y over. Okay, let me explain what happened here. Only 3 terms in the equation, right? 6x remain on the left side. So 6x is still 6x on the left side. I move the 7 over to the left side, so 7 become -7. And then move negative y from left to the right, so negative y become positive y. And that's how do I have y equals 6x minus 7. Y equals mx plus b. Yeah, so tell me what is the slope? Positive 6, right guys? Slope of L is positive 6. Positive 6. Very good. Thank you guys for sharing. So we can let L is y equals 6x plus b. 6x plus b. And now since 3, 8 is on L, x equals 3, y equals 8, is going to satisfy the equation y equals 6x plus b. Be careful, the 6 and the b do not confuse one with each with another. Y is 8, plugging in y equals 8, plugging in x equals 3. 8 equals 3 times 6, 18, plus b. Think about what's the value of b, which value added to 18 gives us 8. It must be a negative number, right? It has to be negative 10. Plugging back, 18 minus 10 gives us 8. So b is a negative 10. So the equation is y equals 6x minus 10. But do not enter that. If you enter that, the system is going to mark as wrong, because the question specifically tells us to write the equation in the standard form. What does standard form look like? Both x and y are on the left side. Constant is on the right side. So this is what we do, okay? Let me get rid of that. We're going to move the y over, move the negative 10 over, and then switch the side. 6x minus y equals 10. I apply the transposition of terms. It's a technique we have been talking about from the very beginning of the semester. Let me repeat what we have done here. I kept 6x on the right side, so 6x still 6x. I moved the negative 10 over to the left, so negative 10 becomes positive 10. I also moved the y to the right side, so we have a negative y on the right side. And then I switched the order. I switched the left side and the right side. I have 6x minus y equals 10. And that's in the standard form. ax plus by equals c. 6x minus y equals 10. See the answer? Same with here, right? 6x minus y equals 10. So be very careful. Since the question asks us to write the answer in the standard form, we really have to follow the instruction. Please let me know. This is a challenging problem, by the way. Please let me know. Do you have any questions? When you repeat enough, when you practice enough, a bigger project, when you get familiar with the project, you will not feel the project that big anymore. It's really doable. It takes time to get familiar with that. No questions so far. Thank you, Joe and Amanda. Okay, let's continue. Simplify. Simplify and write your answer with only positive exponents. Yeah, I explained. An algebraic expression is seen as not simplified if the expression contains negative exponents. So we will have to get rid of negative exponents if we have any. So in this case, let's see how do we get rid of them and simplify the expression. Firstly, I saw the 2 on the top and the 8 on the bottom. 2 over 8 is 1 over 4. So the 2 will be cancelled from the numerator, and we will have a 4 on the denominator. That's the first thing I notice. Secondly, we have a cube on the top. We have a to the power of 95 on the bottom. So here, I'm going to change a to the power of 95 in the denominator to a to the power of 5 in the numerator. I'm going to change b to the power of 96 in the numerator to b to the power of positive 6 on the denominator. B to the power of 95 in the denominator, change it to b to the power of positive 5 in the numerator. Let me use the color to demonstrate what happened here, all right? What happened is this pink in the denominator become this pink in the numerator. Change color. This blue in the numerator become this blue in the denominator. Change color. This yellow in the denominator become this yellow in the numerator. Okay, guys. So the a to the power cube stay on the top. We did not change that part. Do you see what happened here? How do we change the blue on the bottom? We get rid of the negative sign and put everything left on the bottom. Reflect. I mean, with respect to the fraction bar, like flip over the fraction bar. It was on the top, but when we remove the negative sign, we're going to put it on the bottom. The pink has a negative sign in the bottom. Once we remove the negative sign, we put it on the on the top numerator. And the yellow has a negative sign in it. We remove the negative sign and we put the yellow on the top. Do you see that? I hope the color scheme, color thing would help us to understand. And now we keep simplify. We have a to the power 3 and a to the power 5 in the numerator. So we are going to have a to the power 8. We have 3 a's here, 5 a's here. So we have 8 a's. And we have b to the power 5, like 5 b's on the top. We have 6 b's on the bottom. And the 5 b's on the top, the yellow, 5 b's on the top will be cancelled. And we will have 1 extra b in blue on the bottom. And that's the result. And let me know if I'm clear. Thank you. Thank you, Joe. Same with our answer, right? A to the power 8th over 4b. Thank you, Amanda. Next, let me copy paste. Evaluate by using scientific notation. Okay. And the laws of exponential expressions, or the law of exponents. Write your answer in scientific notation. Okay. So let's see what we have in this expression. We have, this is a number, this is another number, this is another number, and this is another number. We have 4 numbers multiplied together, right? Let's write each of them in a scientific notation. Let's do the yellow first. The yellow is a large number. Remember, what does a scientific notation look like? The first part has to be a number bigger than or equal to 1 and strictly less than 10. And second part has to be a power of 10, right? If the exponent, if the number is large, the exponent is positive. If the number is small, the exponent is negative. So here, 120 million, we can write it as 1.2. Place the decimal point between the first and the second digits. 1.2 times 10 to the power, how many zeros here? 8 0. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's the yellow. And let me know if you have any questions. It's the yellow. Multiply by. Okay, thank you. Multiply by the blue. Let's see the blue. Well, I can use the parentheses like what it has before. So this is the yellow. And the blue is here. Blue is here. Pink or purple. Purple is here. Green is here. You can play with it, make it looks nice. Make the reasoning and your solution as clear as possible. If you have a child or you have a nephew, that I think is good strategy that you can teach your children or your nephew. If you understand very clearly, so if you want to teach your child, then you have to be very clear about what's going on, and that's a very good way to learn things. The best way to learn is teach, right? Let's see the blue. The blue is 0.00004. So we're gonna have 4 times 10 to the power negative, because this is a very small number, tiny number. So we're gonna have a negative exponent on the short of 10. It's gonna be 1, 2, 3, 4, 5, -5. All right. Pink is 0.0005. So we're gonna have 5 times 10 to the power negative exponent. 1, 2, 3, 4, -4. Green is a large number, so we're gonna have 7 times 10 to the power 1, 2, 3, 4, 5. Double check. Let's double check, because even just one tiny mistake, like counted wrong, the answer will be wrong. Let me double check. So here we have a 1, 2, 3, 4, 5, 6, 7, 8, 8 power of 8 on the short of 10, 1.2. So this is 4 times 1, 2, 3, 4, 5, 95. And this is 5 times 1, 2, 3, 4, 94. This is 7 times 10 to the power 5. Okay, everything looks fine. And then what do we do? And then we are going to multiply this by this by this like this. And we're going to use the calculator, okay? Or let me write them together first. So now we're going to write 1.2 times 4 times 5 times 7, and then multiply by 10 to the power of 8 times 10 to the power of 95 times 10 to the power of 94 times 10 to the power of 5. So I put the first part of the 4 scientific notations in the first parentheses, 1.2 times 4 times 5 times 7, and then put those power of 10s in the second parentheses. 10 to the power of 8 is 95, 94, 5. And then I'm going to use my calculator to multiply 1.2 by 4 by 5 by 7. I have 168. And then multiply by, let's see what happened to the second parentheses. Using what? Product rule, guys. Use the product rule, okay? 8 minus 5, 3. 3 minus 4, negative 1. Negative 1 plus 5, positive 4. Well, we can see that this guy and this guy actually cancel each other, because they are reciprocal. They multiply to 1. Negative 5 plus 5 is 0. 10 to the power of 0 is 1. And 8 minus 4 is 4. But, guys, this is not your answer, okay? This is not your answer. If you place that in the cell, you get it wrong. You get it wrong. So let's recall, what does the scientific notation look like again? The first part must be a number bigger than or equal to 1 and strictly less than 10. And 168 is not a number bigger than or equal to 1, less than 10. Too big. It's too big. So we have to rewrite 168 as 1.68 times 100, right? And the 100 can be written as 10 to the power 2. And then bring down 10 to the power 4. So we have 1.68 times 10 to the power 6. And that's the answer. The question requires us to write a result in a scientific notation. Then we will have to do that. And in the scientific notation, the first number has to be bigger than or equal to 1 and strictly less than 10. I see the result. It should be the same with, you see the same with the answer, right? If you enter 168 times 10 to the power 4, that would be wrong. And you waste all the energy earlier. And this question is different. It's actually a little challenging. It's a little challenging. It has so many steps, right? And let me know, do you have any questions? It's a pretty good question. Firstly, we convert from the standard form to scientific notation. And we simplify, use the product rule, and then we have to rewrite the result in the scientific notation again. Questions? Okay, I hope it's clear. If you need more help, you can either email me or watch the video. Let me see if I'm recording it. Oh yeah, I'm recording. Okay, continue. Slope and y-intercept. This one, okay, is not a challenging problem, but it is a good problem from chapter 3. We are looking for slope and intercept. Well, if the equation is in the slope-intercept form, I believe most of you know how to find the slope and intercept. But look at the equation now, it's not. the equation actually right now is in a standard form. 2x minus 3y equals 1. So what are we going to do is we are going to rewrite the equation in the slope-intercept form. And how do we do that? We are going to solve the given equation for the variable y. In other words, we are going to isolate the variable y on the left side. This is what we do. We keep negative 3y on the left side, move 2x over, keep 1 on the right side. Okay, let me repeat what have happened here. So we only have 3 terms, right? Green, yellow, blue, in the middle, I use the red line to separate the left side and the right side. This is the left side. This is the right side. So what happened is the yellow term remain on the left side. Blue term remain on the right side. All I did is to move the green term from the left side to the right side. So the sign have changed. When we change the side, we have to change the sign as well. We move the green term from the left to the right, we flip the sign from positive to negative. So now we have negative 3y equals negative 2x plus 1. Remember, we are solving for y, isolating y on the left side, almost there. And then we divide everything by negative 3. Divided negative 3 by negative 3, divided negative 2 by negative 3, divided 1 by negative 3. And they cancel. We have a y equals negative 2 over negative 3 is a positive 2 over 3. 1 over negative 3 is negative 1 over 3. I would say the challenging part actually is this like a fraction thing. And we have a y equals 2/3 times x minus 1/3. And the equation is in the slope-intercept form right now. Y equals mx plus b. And now you can tell what's the slope and what's the y-intercept. Be very careful. Y-intercept is not a number, it's a pair. So slope is 2/3. Y-intercept is 0, negative 1/3. Firstly, let me know if I'm clear about the solution. The plan is to rewrite the given equation in a slope-intercept form. Then we would be able to identify the slope and the y-intercept directly, right? To rewrite the equation in a slope-intercept form, we solve the equation for y. We firstly move the green term over to the right, and then we divide all the terms by negative 3. And let's see the answer here. 2/3, slope is 2/3. Again, you see the y-intercept, do not just enter negative 1 over 3. Read the instruction here. Type and word the pair. Simplify your answer. The y-intercept is a point. A point in the rectangular coordinate system has 2 components. So the corresponding algebraic expression is going to be a pair, ordered pair. It has 2 components, 0, negative 1 over 3. We have mentioned that a lot of times. Questions? Okay. Thank you for your response, Amanda and Joe. I hope they are not the only 2 online right now, okay? Since I do not require you have to show your face, because I'm not. But I hope you are engaging. for your sake, we are reviewing, right? This is supposed to help you are taking the exam. Next is to graph a linear inequality in two variables. Do not get confused if you see the inequality only has one variable. Graph the region described by the inequality. This chapter, when you go to the exam, exam 2 covers chapter 3 and chapter 5. All the inequality, if you see an inequality, it's gonna be a linear inequality in two variables. Okay, do not worry about, I do not see why. You will understand. Let me explain. So firstly, we're gonna switch or change the inequality symbol to equal sign. And we have x equals 4. And that is the boundary line of the region we're looking for. And the region represents the solution set of the inequality. Question, what kind of straight line that is? X equals 4 represents a straight line in a rectangular coordinate system. What kind of line that is? Vertical. Thank you so much. Exactly, it is vertical. It is a vertical line. Okay, let me see if I can. It won't let me do it. I'll graph on my note. It is a vertical straight line. So we are going to draw the line 1, 2, 3, 4. Draw a vertical line. Dashed or solid? Dashed or solid? Solid, exactly, because the original inequality symbol is bigger than or equal to, right? And then we are going to determine, are we going to shade the region to the left or are we going to shade the region to the right? I would use a testing point, 0, 0. The inequality is x is bigger than or equal to 4. If I plug in x equals 0, I have a false statement. I have a false statement because 0 is not bigger than or equal to 4. That means the 0, 0 is not a solution. That's the reason we are going to shade the region to the right. Okay? And also think about x is bigger than or equal to 4. X is bigger than or equal to 4. You have to shade the region to the right because this is a 4 and this is a 5, 6, 7. The right side of the boundary, they are bigger than or equal to 4. Those points, their x values are bigger than or equal to 4. So that's also something that you can understand is going to be on the right side. Yeah, shade the right. Exactly. Thank you, Dakota. Thank you for your response. Next, find an equation. Let me copy paste. Find an equation of the line that has the given slope and pass through the given point. Okay. And let's see what also here. Type your answer in slope-intercept form. That's something we need to follow. Slope-intercept form. Slope-intercept form. Okay, yeah, to start. Awesome, very good, perfect. Thank you, Dakota. 0, -95. Let me double check yours. So y is 0, x is 95, 6 plus b, perfect. I'm happy because it means you paid attention. Very good. So the slope in the subject for is y equals mx plus b. And yeah, you are right. This is x. You're gonna plug in x equals 95. You're gonna plug in x equals y equals 0, y equals 0, and you plug in m equals 6. So y is 0, m is 6, x is 95. We keep b here. B is gonna be the only unknown in the equation. Let's solve the equation for b. 0 on the left side, right side 6 times 95, negative 30 plus b. Think about which number minus 30 gives you 0. It has to be 30. B has to be the opposite of negative 30 in order to get a sum equal to 0. So B equals 30. So that's how do we know the answer is going to be y equals 6x plus 30. 6x plus 30. Perfect. Very good. And your answer in the cell is going to be y equals 6x plus 30. There is a way you can double check your answer. You're plugging in x equals negative 5, y equals 0. You must have a true statement if your answer is true. All right? Oh, that's the last question. I would say keep practicing. The review questions are pretty similar with the actual question on the test. Let's see, 6%, 60%, 24 out of 40. Let me double check everything that we have done. Oh, it actually doesn't show anymore. I believe the questions we have done are correct. Oh, it's here. Okay, very good. All right, guys. Do you have any questions about the review? Get a calculator, scientific calculator. And if you want to take the exam on the Saturdays, figure out the hours. Okay? This Saturday is the last day to take the exam. How about let's look at the announcement I posted here. Exam 2. You have until April 20th. April 20th. If you go to your Pearson, exam 2, look at here. Exam 2, 120 minutes. In front of the exam 2, you have April 20th. So that is the due. I think my time window for you to take exam 2 very generous. 2 weeks and including 2 Saturdays. I hope you do not need extension again. Try to get it done within the time frame. What day is the last day again? Is April 20th. Just saw it. Thank you. Okay. Thank goodness. Okay. I need a bit more practice. Okay, for sure. Exactly. Practice make perfect. We have 8 minutes. I need a lot more. Okay. Yeah, Kayla, if you have any questions, you can ask now.
I think it's just getting everything together. I think it's just a lot of mumble jumble right now, but I'm going back and watching the classes and taking notes and everything. So hopefully, I'm taking the test next week. So hopefully, by the time the exam comes around, I get it down better.
Oh, okay. Yeah, you are welcome to email me if you need any other help. Like we can Zoom. Okay.
Okay, I might do that then. Thank you so much.
No problem. Alright, guys, if you have questions, please stay. If you have no questions, I'll see you on Monday. Today is Wednesday. Yeah. Have a good night.
How do we go back and watch the videos of the class that you record?
That's a good question. Let me show you. So this is the menu in the Blackboard, right? And you go to virtual classroom. And there's a sandwich right here. And recordings. And all those past classes have the recordings here. Did I answer your question? Okay, no problem. No problem. Have a good evening. See you next Monday, Amanda.